Exercise 1.2, question number 7. AB parallel to CD and CD is parallel to EF. Find X and AE. See in the figure, AB is parallel to CD and CD is parallel to EF. By the property of three parallel lines and their transversals, we can say that this BD upon DF should be equal to AC upon C. That means 8 upon 4 must equal to 12 upon X. By cross multiplication, we can have 8 into X equal to 12 into 4. Now into 8 will become upon 8 now. 4 ones are 4, 4 twos are 8. 2 ones are 2, 2 sixes are 12. So X should be equal to 6. Once again, the property is if the three parallel lines are there, then intercepts made by them are in proportion. That means this BD upon DF is equal to AC upon C. That is the property. Question number 8. In triangle element, ray MT bisect angle element. If LM equal to 6, MN equal to 10, TN equal to 8, then find LT. As ray MT is bisector of angle element, therefore we can say that this LT upon TN should be equal to LM upon MN. The bisector of angle bisect the side opposite to the angle in the ratio which is equal to the ratio of the remaining sides. That means LT upon TN should equal to LM upon MN. LT upon 8 should be equal to 6 upon 10. See here. 2 3s are 6, 2 5s are 10. By cross multiplication, LT into 5 will give you 3 into 8. Into 5 will become upon 5. 3 8s are 24 here. 24 upon 5 will give you 4.8. 5 4s are 20. Remains 4 becomes 40. After decimal place we will write 5 8s are 40. Question number 9. Find the value of X. Here BD segment divides angle ABC into equal parts. That is, BD is a bisector of angle ABC. By angle bisector theorem, we can say that AD upon DC should be equal to AB upon BC. That means X minus 2 should be equal, X minus 2 upon X plus 2 should be equal to X upon X plus 5. Cross multiplication, X minus 2 into X plus 5 equal to X into X plus 2. Multiplying now, X into X will give you X square, X into 5 will give you 5X, 2 into X will give you 2X, 2 into 5 is 10 here. Minus 2 into 5 will give you minus 10 here. X into X is X square, X into 2 is 2X, plus X square will come to this side and will become minus X square. So X square will get cancelled. 5 minus 2, 3X. This plus 2X comes to this side and will become minus 2X, minus 10 will go to that side and become plus 10. 3X minus 2X, 1X, X equal to 10. Hence the answer. Once again, the angle bisector theorem is the bisector of the angle divides the side which is opposite to the angle in the ratio which is equal to ratio of two remaining sides. Here it is AD upon DC, that should be equal to AB upon BC. Question number 10. In triangle DEF, PQ parallel to DE. This PQ is parallel to this DE. Okay. So we can apply the basic proportionality theorem in triangle XDE. we can write xp upon pd equal to xq upon qe. Okay, another thing given is QR parallel to EF. This QR is parallel to this EF. Then in triangle XEF, by basic proportionality theorem, see here, we can write XQ upon QE should be equal to XR upon RF. By Roman 1 and Roman 2, we can conclude that XP upon PD, that should be equal to XR upon RF. See here, because XP upon PD is equal to XQ upon QE and XQ upon QE is equal to XR upon RF. As XP upon PD becomes equal to XR upon RF, therefore in triangle XDF, by converse of basic proportionality theorem, we can conclude that PR is parallel to DF. In the problem, in short, we can say if we are trying to show that PR is parallel to DF, then we should know the ratio of XP upon PD and XR upon RF. But XP upon PD is equal to XQ upon QE by basic proportionality theorem. XR upon RF is also equal to XQ upon QE by basic proportionality theorem because QR is parallel to EF. Therefore, in triangle XEF, we can apply the basic proportionality theorem. Similarly, in triangle XDE also, we can apply basic proportionality theorem. Therefore, XP upon PD will become equal to XR upon RF, and then by converse of basic proportionality theorem, we can say that XP is parallel to DF. Okay, once again, if you are trying to show that PR is parallel to DF, then you should try first XP upon PD, that should be equal to XR upon RF. But to have XP upon PD, we have this triangle XDE in which PQ is parallel to DE. And for XR upon RF, we have the triangle XEF in which QR is parallel to EF. In both the triangles, we can apply basic proportionality theorem. That means XP upon PD should be equal to XQ upon QE. Similarly, XR upon RF is equal to XQ upon QE. Therefore, XP upon PD will become equal to XR upon RF because both are equal to XQ upon QE. Therefore, these two ratios are equal. As these two ratios are equal, therefore PR is parallel to DF by converse of basic proportionality theorem. Okay. Now question number 11. In triangle ABC, ray BD bisect angle ABC and ray CE bisect angle ACB. If AB equal to or segment AB is congruent to segment AC, then prove that AD parallel to BC. As ray BD bisect angle ABC, ray BD bisect angle ABC. Therefore, we can say that AD upon DC equal to AB upon BC. Okay. Now, ray CE bisect angle ACB. Therefore, we say AE upon EB equal to AC upon CB. Okay. In Roman 1 and Roman 2, denominator is BC here of the right hand side ratio, and numerator is AC and AB, but AB and AC are equal, it is given. Segment AB is congruent to segment AC, it is given. Therefore, from 1, 2 and 3, as these two ratio AB upon BC equal to AC upon BC, because AB equal to AC and BC are already same, therefore AB upon BC should be equal to AC upon BC, and therefore AD upon DC should be equal to AE upon EB. Okay. Therefore, for Roman 1, 2 and 3, we can conclude that AE upon EB equal to AD upon DC. See here, AE upon EB, if it is equal to AD upon DC, then by converse we can say that, converse of basic proportionality theorem, we can say that ED is parallel to segment BC or side BC. Once again, in short, if you are trying to show that ED is parallel to BC, then you should show that AE upon EB equal to AD upon DC. But AE upon EB is equal to AC upon CB by angle bisector theorem. And AD upon DC is equal to AB upon BC. As this AB and AC are equal, therefore the ratio AB upon BC and the ratio AC upon BC are equal. And therefore we can say that AE upon EB is equal to AD upon DC, and hence the theorem or hence the property we can prove that ED is parallel to BC. Now practice set 1.3. In triangle CDE and triangle CBA, we want to show that these triangles are similar. Given information, angle CDE and angle B are of 75 degrees. Therefore we can write them as they are congruent because each of 75 degree. As angle DCE is equal to angle ACB, it should be angle ACB. Okay, this angle DCE should be equal to angle ACB because of common angle. Therefore triangle CDE is congruent to triangle CBA. C is the common angle, therefore correspondence of C with should be equal to C. Here D is of 75 degree and here B is of 75 degree. Therefore D should have 1-to-1 correspondence with B. Therefore we are writing here triangle CDE similar to triangle CBE by AA test of similarity. Two angles of one triangle are congruent with two angles of other triangle. Then the two triangles are similar by AA test of similarity. Here the correspondence is CDE 1:1 correspondence with CBA. C is the common, therefore C should get correspondence with C. D is 75, B is 75 here, so D should have 1-to-1 correspondence with B and E should have 1-to-1 correspondence with A. Therefore the correspondence here is CDA 1:1 correspondence with CBA. Question number 2. Are the triangles similar? In triangle PQR and triangle LMN, we will check the ratios of the corresponding sides here. PQ upon LM, that means 6/3, it is 2:1. QR upon MN, 8/4, that is 2:1. PR upon LN, that is 10:5, that is also 2:1. From 1, 2 and 3 we can say that PQ upon LM is equal to QR upon MN is equal to PR upon LN. As the corresponding sides are in proportion. All the corresponding sides, that is 3 corresponding sides of one triangle, are proportional with 3 corresponding sides of other triangle. Then the triangles are similar by SSS test of similarity. Which test it is? SSS test of similarity. Now question number 3 is, two poles are perpendicular to ground. PR parallel to AC. Okay, as they are perpendicular to the ground, they should be parallel. And sun rays are parallel to each other. We know that sun rays are always parallel to each other. Therefore, AB is parallel to PQ. Hence, we can conclude that the shadow cast at same time should be in proportion, and it is always in proportion. The shadow cast at same time is always in proportion. Therefore, triangle PRQ is similar to triangle ACB. If triangles are similar, then corresponding sides are in proportion. Therefore, PR upon AC is equal to QR upon BC is equal to PQ upon AB. That is 4 upon 8 is equal to 6 upon X. 4 ones are 4, 4 twos are 8. By cross multiplication, 1 into X is equal to 6 into 2. 1 into X is X, 6 twos are 12. Therefore, shadow of the bigger pole at same time will be 12 meters. Here the shadow cast by the smaller pillar was 6 meters, and the shadow cast by the bigger pillar or greater pillar should be of 12 meters here. If it is 6 here it should be 12. Okay, so thank you very much. Thanks a lot.